Hey guys, I had told you via email that there was one last skill that we needed to learn before we took our Unit 2 exam, and that skill is dealing with mass percents. So for example, this is an acid-base question, but rather than giving you the concentration of HCl, they give you the mass percent. So I'm just going to read this and we'll talk through it. So a solution of hydrochloric acid is 38.0% hydrochloric acid by mass. And it has a density of 1.189 grams per milliliter. They want to know what volume of 1.25 molar potassium hydroxide, the base, would be required to neutralize 15 milliliters of this hydrochloric acid solution. So the first thing I want to say is that mass percent is just another way of expressing concentration. So what does it mean when they say that the solution is 38.0% hydrochloric acid by mass? I'm going to show you several ways of representing what this means. Okay, they're telling you that HCl makes up a certain amount of mass of the entire solution. Okay, so just as we would normally say, hey, there's a certain amount of moles per liter of solution, this time we're saying there's a certain number of grams of HCl per grams of solution. So hydrochloric acid makes up a certain fraction of the total mass of the solution. And to turn that into a percentage, times 100%. Okay, so that's one way of representing this. Mass percent can also be expressed as a conversion factor. So whenever you read 38.0% by mass, you could interpret that as, hey, that's the grams of solute per 100 grams of solution. Okay, in other words, there's 38.0 grams of HCl, that's what's dissolved, in 100 grams of the entire solution. And the solution is made up of HCl and water, right? Because it's an aqueous solution. So one thing you want to be able to do is convert between mass percent and density as a way of expressing concentration to molarity. So you might want to pause the video and just try to work that out for yourself. If you were given mass percent like we are here and density of the solution like we're given here, maybe think through how would you use those two conversion factors to convert to molarity. And when you're ready, you can unpause and I'll kind of talk you through it. So just a reminder, molarity, moles per liter of solution. And really to specify, moles of solute. So moles of HCl per liter of aqueous solution. Density, okay, when they give us 1.189 grams per milliliter, both of those units are about the solution. So they're giving you grams of solution per liter, milliliter, right, that they gave us, all right? Of solution. So that's an interesting difference. Molarity is talking about how much solute is there per liter of solution or volume of solution. Density is all about the solution. How many grams per milliliter of solution do you have? Mass percent, okay, more similar to molarity, is telling you how many grams of solute per 100 grams of solution. Okay, so if you were asked to take a mass percent and you want to go to molarity, I'm just going to start by writing out the mass percent. There's 38.0 grams of HCl, my solute, per 100 grams of solution. So we need to take grams of HCl and convert it to moles of HCl if we're going to go from mass percent to molarity. So as part of our plan, this needs to be converted to moles. Convert to moles of HCl. Okay? 100 grams of solution is going to need to be converted to a volume. We're going from a mass to a volume. Density is the only conversion factor that lets us do that. So this is going to convert to volume, in this case in liters of solution. Okay. You can start with the conversion of grams of HCl to moles or grams of solution to liters of solution. It doesn't matter which one you tackle first. I'm going to go ahead and get us into, take this 100 grams of solution and get us into liters of solution. I'm going to do that work in blue. Okay. We have 100 grams of solution, and we know the density of the solution. It's given to us up here. Okay, we know that there's 1.189 grams of solution for every 1 milliliter of solution. Great. Units cancel. Now we're in milliliters of solution. That's wonderful. We just need to get to liters of solution. So all we're going to do is convert 1,000 milliliters to 1 liter of solution. Okay. And milliliters cancel. Just to be clear, this is of solution. Okay. So basically, multiplying this by the density and by 1,000 gives you liters of solution. Now what you have to do is take this 38 grams of HCl and get it to moles, which is something you're used to doing, right? You just need the molar mass of HCl. So though there's a big gap, you can imagine starting here, and you're going to need to get grams of HCl on the bottom, and you're trying to go to moles, HCl on the top. So if you worked out the molar mass, let's see, I have a periodic table, H and then Cl. So H is 1.008 grams per mole. Cl is 35.45. 35.45. Okay, so 8, 5, 4, 36.46 basically grams per mole. So 36.46 grams in 1 mole of HCl. Okay, so you can see that our units now are moles of HCl per liter of solution. We're in molarity, so we just need to use a calculator and multiply your 38 times 1.189 times 1,000, and we're dividing that entire quantity by 100 times 36.46. And I came out with 12.39 molar. Let's think about sig figs. There's 3 sig figs limiting your answer. So we're going to call it 12.4 molar. We would round if this is what the problem was asking for, which it is. Convert to molarity. So that's a pretty concentrated solution of hydrochloric acid. It means you got 12.4 moles for every 1 liter of solution. Okay, now often the problem is not going to ask you for the molarity. Like in this case, they give you concentration via mass percent and density. And what they're really wondering is if you had 15 milliliters of this solution, how much potassium hydroxide, or how much base, if the base is 1.25 moles per liter of potassium hydroxide, would be required to neutralize 15 milliliters of the solution. So we've done problems like this when everything is in molarity, and now the goal is to use mass percent and density to solve a complete neutralization problem. So I'm going to move this up, give us some space. It's always a good idea when you're talking about a neutralization reaction or any reaction just to write out the balanced molecular equation so you can think about the ratios that the reactants are reacting in. So this is aqueous HCl, hydrochloric acid, plus aqueous potassium hydroxide. Okay, the H and the OH react to form water. All acid-base reactions are going to form water as a product. And what's left over are the spectators, chloride and potassium, KCl. So notice everything here is 1 to 1. If you wanted to write out the NIE, you would have H plus aqueous plus OH minus aqueous makes water. Okay? So the moles of H plus are going to equal the moles of OH minus in any neutralization reaction, and we see here they're reacting in a 1-to-1 ratio. So your first step is really to figure out, find how many moles of H plus are in the solution that's 38.0% HCl by mass. If you have 15.00 milliliters of it like they asked for. So again, how many moles? So in 15 milliliters, those are the two kind of big pieces of information. If we knew how many moles of H plus we had, then we would know that moles of H plus are going to equal moles of OH minus, since this is neutralization. And since there's 1 OH for every 1 KOH, that's going to tell you how many moles of KOH you need. And we can use molarity as a conversion factor to then convert to liters of KOH. Okay? So here we go. We're going to start by doing some work to figure out how many moles of H plus are in 15 milliliters of the solution. So this is what you're given, 15 mils. And 15 mils of the solution. So that doesn't mean you have 15 milliliters of pure HCl. You have 15 milliliters of solution, and that solution has a specific mass percent of HCl. So I want to convert my milliliters of solution to grams of solution so that I can then use my mass percent as a conversion factor. So I'm going to start with here the density. Okay, the density of the solution for every 1 milliliter of solution, there's 1.189 grams of solution. Okay, so milliliters have canceled. Now that I'm in grams of solution, my brain is thinking, ding, 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 mass percent, right? Because I know that 100 grams of solution, for every 100 grams, there's 38.0 grams of that is HCl. So basically 38% is HCl. This right here is your mass percent. I'm just kind of calling out to you what the conversion factors are that you're using. All right, we've gone from grams of solution to grams of HCl. That's great. We're getting closer to moles of H+. We now need to convert from grams to moles. So we're going to use that molar mass that we found in the previous problem. There are 36.46 grams of HCl for every 1 mole of HCl. Okay. That's lovely. We know, since there's 1 H plus for every 1 HCl, we know that moles of HCl are basically going to equal moles of KOH. So I'm going to use the mole ratio. 1 mole of HCl for every 1 mole of KOH. That's great. Now I'm in moles of KOH like I want it to be, and my last step is to convert to liters of KOH. And I can do that with the molarity. So I know that there's 1.25 moles of this KOH solution. Sorry, there's 1.25 moles of KOH in 1 liter of solution. And the problem just said what volume, it didn't specify what unit, so I'm going to leave it in liters. Okay, so again, all we need to do is multiply all these digits in the numerator and divide by the quantity in the denominator. So 15 times 1.189 times 38 divide by 100 grams times 36.46 times 1.25. Okay, and that is all equal to 0.14870. You know, I could keep going. So how many sig figs? 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So 3 is limiting. So this 7 tells me that 8 is going to round up. 0.149 liters of the KOH solution of the 1.25 molar KOH solution. If they wanted it in milliliters, you could just say 149 milliliters of it. Great. So I'm posting this worksheet along with another practice problem on the home page under the day we did electrolytes lab, because I was intending to have this as part of a pre-lab lecture. So that document will have one more practice for you. I would suggest going there, printing it out, trying this on your own first, and now I'm going to work it out for you. But please practice on your own before you kind of see what I'm doing to work it out. And I just have to log back into my computer to make sure we're still filming. All right, we're still going. Okay, so this says a solution of acetic acid is 36% acetic acid by mass and has a density of 1.045 grams per milliliter. What volume of a 1.5 molar sodium hydroxide solution will be required to neutralize 10 milliliters of the acetic acid solution? And this problem adds an extra step. What is the concentration of all the ions left in solution after the reaction? Okay, I would suggest always starting by writing out the balanced molecular equation and getting a sense for the mole ratios. So we've got sodium hydroxide, NaOH, aqueous, reacting with the acid, acetic acid. So HC2H3O2 aqueous. Okay. What is that going to produce? Water. This is an acid base reaction. And sodium acetate. So NaC2H3O2, and that's aqueous. Okay. Sometimes it's helpful just to organize everything you have. So this problem's saying you've got 10 milliliters of the solution. And they tell us the solution has a density 1.045 grams of solution per milliliter of solution. And mass percent, so 36.0 grams of acetic acid per 100 grams of solution. I'll erase this. I don't know what my brain was doing. Solution. So it's really important to differentiate. Am I talking about a volume of solution or moles of solution or grams of solution, or am I talking about acetic acid or the solute? Okay. So I do think it's useful to kind of rewrite each of these with the proper units. What do we know about NaOH? Well, we don't know the volume. We don't know how many liters we're going to add to neutralize 10 milliliters of the solution. But we do know that there's 1.500 moles of NaOH per liter of solution. Okay? So each of these is a conversion factor: mass, percent, density, and molarity. So start here with the volume that you've been given. It's not a conversion factor. Okay? What you want to do, because this is a complete neutralization problem, this is a scenario where you have to ask yourself, how many moles of H plus are in the 10.00 milliliters of the solution? Okay, and something to be clear about, acetic acid is a weak acid. So if you were going to draw a molecular view of it, you would show one dissociated and then several that are undissociated, that are together. Needed a bigger box. Okay. Even though there's maybe only one dissociated at a time, when you add a strong base, this hydroxide is going to react with all of the H's. So it's going to rip off an H plus from the remaining acids. So you don't have to know how much is dissociated. That's not what we're asking. We're asking how many total moles of H plus are there in the solution. So that's going to be basically equal to moles of acetic acid. Okay, so I'm going to move this up a little bit. And we'll do the work. So we're starting with this 10 milliliters. I'm going to try to leave a lot of room here. 10.00 milliliters of solution. Now, I'm trying to figure out moles. So first, I know I'm in milliliters of solution. What is the only conversion factor that has that? The density. So I want to cancel out milliliters of solution, and that's going to take me to grams of solution. So there's 1.045 grams of solution for every 1 milliliter of solution that you have. Okay. Now, ultimately, we want to know something about moles of acetic acid. But right now, we're not talking about grams of acetic acid, we're talking about grams of solution. So what can take us from grams of solution to grams of acetic acid? The mass percent. So that mass percent tells us there's 100, for every 100 grams of solution, you're going to find 36.0 grams of acetic acid dissolved. Okay, so grams of solution cancels. Grams of acetic acid, now that's great, but I wanted to find moles of it. So I'm going to need the molar mass. And I believe the molar mass is 60.05 grams of acetic acid. Oops, this is running out. For every 1 mole of acetic acid. Okay, so grams of acetic acid cancel. That's great, I've found it. And I know that the acetic acid and the sodium hydroxide react in a 1-to-1 ratio. There's 1 H plus for every 1 OH minus. So I'm going to use that mole ratio. For every 1 mole of acetic acid, there's 1 mole of base, NaOH. Okay. Last thing is they wanted to know how many milliliters, right? They want to know, liters. They didn't really specify. So how do we go from moles of NaOH to liters of solution? It's the molarity. So imagine that I had more space. I'm just going to write it down here. So basically times, I'm canceling out moles of NaOH. So there's 1.500 moles of NaOH for every 1 liter of solution. And so we cancel moles. Whew, okay, so now you need to plug everything into your calculator. 10 times 1.045 times 36, all divided by 100 times 60.05 times 1.5. And I've got 0.041765 liters of solution. Do I need all those digits? 4 sig figs, 4 and 3. 1, 2, 3. So 0.0416 tells us 7 to round up. 8 liters of the NaOH solution. Okay, great. So there's a second practice. I think what I'm going to do, because on the office hour discussion sheet, people wanted more stoichiometry. So I'm going to post, in addition to these two problems, a few kind of harder departmental problems, and then I will post a key where those problems are worked out. And I will be seeing you all very soon in office hours.